Our 10th lecture video on properties of matter will continue the discussion on density and specific gravity. In the last video, we looked at how to calculate mass density and weight density. Let's now talk about the density of water. The mass density of water is 1,000 kilograms per cubic meter. This means that 1 cubic meter of water has a mass of 1,000 kilograms. The weight density of water is 62.4 pounds per cubic foot. This means that 1 cubic foot of water weighs 62.4 pounds. It is important to note again that you will need to convert units to make sure we have correct units when talking about mass density or weight density. You will also need to feel comfortable with various volume equations. For our class, you can find these volume equations in your textbook. Sometimes you might encounter an object who has an irregular shape or one that you don't know how to calculate its volume. In these cases, the density of irregular solids cannot be found directly because there are no easy ways to calculate the volume. Instead, you can find the amount of water the solid displaces. The amount of water the solid displaces will have the same volume as the irregular object. This is true because the density of water is 1 gram per cubic centimeter or 1,000 kilograms per cubic meter. We will discuss more about why this is true in the next chapter. Sometimes you may encounter a situation where you want to compare the density of two materials. In this case, you will compare the density of each material to the density of water. The specific gravity is the ratio of the density of the material to the density of water. To find specific gravity, we will take the density of the material in kilograms per cubic meter and divide it by the density of water in kilograms per cubic meter. Specific gravity does not have any units because you are dividing a density by a density. Let's take a look at an example relating to specific gravity. The density of seawater is 64.0 pounds per cubic foot. Find its specific gravity. First, we will write down everything that we know. We know the density of the material, in this case seawater, is 64.0 pounds per cubic foot. We know the density of water is 62.4 pounds per cubic foot. We are trying to find the specific gravity of seawater. The basic equation we can use to find the specific gravity is that the specific gravity is equal to the density of the material divided by the density of water. This is also our working equation as we are trying to find specific gravity. Next, we can substitute in our data. The specific gravity is equal to 64.0 pounds per cubic foot divided by 62.4 pounds per cubic foot. This gives us a specific gravity of seawater of 1.03. This means that seawater is 1.03 times as dense as water, so it would sink if you mixed water and seawater. Now that we know how to find specific gravity, let's take a look at what it actually means. In general, the specific gravity of water is exactly 1. The specific gravity of an object that is more dense than water is greater than 1. If the object is more dense than water, it will sink when placed in water, like a rock. The specific gravity of an object that is less dense than water is going to be less than 1. If the object is less dense than water, it will float on top of the water. This means that if the object has a specific gravity of less than 1, it will float on top of the water like oil. This concludes our discussion on density, specific gravity, and our discussion on properties of matter.